Lesson 3. Newton's Second Law. Reading Guide. Key Concepts. Essential Questions. What is Newton's second law of motion? How does centripetal force affect circular motion? Vocabulary. Newton's second law of motion. Circular motion. Centripetal force. Inquiry. What makes it go? The archer pulls back the string and takes aim. When she releases the string, the arrow soars through the air. To reach the target, the arrow must quickly reach a high speed. How is it able to move so fast? The force from the string determines the arrow's speed. How do forces change motion? Think about different ways that forces can change an object's motion. For example, how do forces change the motion of someone riding a bicycle? The forces of the person's feet on the pedals cause the wheels of the bicycle to turn faster and the bicycle's speed to increase. The speed of a skater slowly sliding across ice gradually decreases because of friction between the skates and the ice. Suppose you are pushing a wheelbarrow across a yard. You can change its speed by pushing with more or less force. You can change its direction by pushing it in the direction you want to move. Forces change an object's motion by changing its speed, its direction, or both its speed and its direction. Unbalanced forces and velocity. Velocity is speed in a certain direction. Only unbalanced forces change an object's velocity. A bicycle's speed will not increase unless the forces of the person's feet on the pedals is greater than friction that slows the wheels. A skater's speed will not decrease if the skater pushes back against the ice with a force greater than the friction against the skates. If someone pushes the wheelbarrow with the same force but in the opposite direction that you are pushing, the wheelbarrow's direction will not change. In the previous lesson, you read about Newton's first law of motion. Balanced forces do not change an object's velocity. In this lesson, you will read about how unbalanced forces affect the velocity of an object. Unbalanced forces on an object at rest. An example of how unbalanced forces affect an object at rest is shown in Figure 16. At first, the ball is not moving. The hand holds the ball up against the downward pull of gravity. Because the forces on the ball are balanced, the ball remains at rest. When the hand moves out of the way, the ball falls downward. You know that the forces on the ball are now unbalanced because the ball's motion changed. The ball moves in the direction of the net force. When unbalanced forces act on an object at rest, the object begins moving in the direction of the net force. Unbalanced forces on an object in motion. Unbalanced forces change the velocity of a moving object. Recall that one way to change an object's velocity is to change its speed. Speeding up. If the net force acting on a moving object is in the direction that the object is moving, the object will speed up. For example, a net force acts on the sled in Figure 17. Because the net force is in the direction of motion, the sled's speed increases. Slowing down. Think about what happens if the direction of the net force on an object is opposite to the direction the object moves. The object slows down. When the boy sliding on the sled in Figure 17 pushes his foot against the snow, friction acts in the direction opposite to his motion. Because the net force is in the direction opposite to the sled's motion, the sled's speed decreases. Reading check. What happens to the speed of a wagon rolling to the right if a net force to the right acts on it? changes in direction of motion. Another way that unbalanced forces can change an object's velocity is to change its direction. The ball in figure 18 moved at a constant velocity until it hit the rail of the billiard table. The force applied by the rail changed the ball's direction. Likewise, unbalanced forces change the direction of Earth's crust. Recall that the crust is broken into moving pieces called plates. The direction of one plate changes when another plate pushes against it with an unbalanced force. Unbalanced forces and acceleration. You have read how unbalanced forces can change an object's velocity by changing its speed, its direction, or both its speed and its direction. Another name for a change in velocity over time is acceleration. When the girl in figure 17 pushed the sled accelerated because its speed changed. When the billiard ball in figure 18 hit the side of the table, the ball accelerated because its direction changed. Unbalanced forces can make an object accelerate by changing its speed, its direction, or both. Reading check. How do unbalanced forces affect an object at rest or in motion? Newton's second law of motion. Isaac Newton also described the relationship between an object's acceleration, change in velocity over time, and the net force that acts on an object. According to Newton's second law of motion, the acceleration of an object is equal to the net force acting on the object divided by the object's mass.
Are we done?
Yeah, you can go. The direction of acceleration is the same as the direction of the net force.
Have a good day.
Okay, bye. Concept check. What is Newton's second law of motion? Newton's second law equation. Acceleration in meters per square second equals net force in newtons divided by mass in kilograms. A equals F divided by M. Notice that the equation for Newton's second law has SI units. Acceleration is expressed in meters per second squared, mass in kilograms, and force in newtons. From this equation, it follows that a newton is the same as kilograms multiplied by meters per second squared. Centripetal force. The ball in figure 19 is in circular motion. The velocity arrows show that the ball has a tendency to move along a straight path. Inertia, not a force, causes this motion. The ball's path is curved because the string pulls the ball inward. In circular motion, a force that acts perpendicular to the direction of motion toward the center of the curve is centripetal force. The figure also shows that the ball accelerates in the direction of the centripetal force. Key concept check. How does centripetal force affect circular motion? The motion of satellites and planets. Another object that experiences centripetal force is a satellite. A satellite is any object in space that orbits a larger object. Like the ball in figure 19, a satellite tends to move along a straight path because of inertia. But just as the string pulls the ball inward, gravity pulls a satellite inward. Gravity is the centripetal force that keeps a satellite in orbit by changing its direction. The moon is a satellite of Earth. As shown in figure 19, Earth's gravity changes the moon's direction.
What do I do?
Similarly, the sun's gravity changes the direction of its satellites, including Earth.
If you're done, you write down your score and your math teacher will want it.
So tomorrow I tell them?
Yeah, or they might ask for it. Yep.
Alright.
Alright, have a good day, Kevin.
You too.
Bye-bye.